Hello everyone, welcome back. In our previous videos, we learned about text preprocessing, part of speech tagging, and named entity recognition. In this video, we are going to learn another important concept in NLP called bag of words, commonly known as BoW. Bag of words is one of the simplest and widely used techniques for converting text into numerical data. So why we need to convert text into numerical data is, since machine learning algorithm cannot process text directly, we need a method to represent text as numbers. So here bag of words helps us to achieve this. In this video we will understand why text should be converted into numbers, what bag of word is, how it will work, and what is vocabulary, and what is the meaning of document term matrix, and what's the advantage and limitations of bag of words. Finally, implement it using Python and Colab. Why convert text into numbers? Before learning bag of words, let's understand why text needs to be converted into numbers. As humans, we can easily understand sentences because we know the meaning of words. For example, consider the sentence, I love NLP. When we read the sentence, we immediately understand that someone likes natural language processing. However, a computer does not understand the meaning of these words. It only sees characters and symbols. So a machine learning algorithm cannot process text such as I love NLP directly. Instead, it requires numerical input. So this creates a challenge in NLP. So what is the solution? The solution is to convert text into numerical vectors. Once text is represented as numbers, machine learning algorithm can process it, identify patterns, and make predictions. This conversion is used in many real-world applications. For example, in spam detections, emails are converted into numbers before classifying them as spam or not spam. In sentiment analysis, reviews are converted into numbers to determine whether they express positive or negative opinions. Likewise, in document classification, news articles or documents are converted into numerical vectors, so they can be grouped into categories such as whether it is sports or it belongs to politics or technology. Similarly, in search engines, convert text into numerical representations to retrieve the most relevant search results. So converting text into numbers is the first and one of the most important steps before applying machine learning techniques to the text. Next, what is bag of words? Let's understand what bag of words actually means. It is a text representation technique that converts text into numerical vectors based on the frequency of words. That means how many times the word occurs. So the word bag means that the order of words is ignored. Only the words present in the document and the number of times they appear are considered. Only it will see how many times the word is present and how many words are present, that only will be considered. So it will not check the order of the word. Let's understand this using the simple example on the slide. We have three documents. The document 1 is I love NLP. Document 2 is I love Python. Document 3 is NLP loves Python. So the first step in bag of words is to create a vocabulary. So vocabulary is nothing but it's a collection of all unique words present in the documents. So from these three documents, the vocabulary becomes I love NLP, Python, then loves. So notice that each word appears only once in the vocabulary, even if it occupies multiple times across the documents. Now the computer uses the vocabulary to count how many times each word appears in every document. So this counting process converts text into numbers. So another important point is to remember, it will not consider the order of words. For example, I love NLP and NLP love I contain the same words. Although these two sentences have different word order, Bag of words treat them as almost the same because it count only word frequencies. This is why the technique is called bag of words. The words are treated like items in a bag where only their presence and frequency matter, not their order. So next is document term matrix. So after creating the vocabulary, the next step is to create the document term matrix. Let's understand this table carefully. This row represents the words in the vocabulary. The column represents the documents. Each value in the table indicates how many times a particular word appears in a document. For example, look at the first row. The word one appears once in a document. 1 and once in document 2 and it does not appear in document 3. Therefore, the values are 110. Now consider the word Python. It does not appear in document 1, appears once in document 2 and once in document 3. Hence the values are 0, 1, 1. Similarly, the word loves appears only in document 3. So its values are 0, 0, 1. If it is present in the document, the value is 1, otherwise 0. So this table is called document term matrix. It's the numerical representation of text generated by the bag of words model. So once we obtain this numerical matrix, it can be directly used as input for machine learning algorithms such as Bayes or logistic regression, support vector machine and many other models. So bag of words acts as a bridge between the text data and machine learning model. Now that we understand how the bag of words model works, let's discuss the advantage and limitations. We'll begin with the advantages. The first advantage is that it is very simple. It is one of the easiest text representation techniques to understand and implement. Even beginners can easily learn how it works. The second advantage is it is easy to implement. So libraries such as Scikit-learn and CountVectorizer. So these are the simple function. It is makes possible to convert text into numerical vectors with just a few lines of Python code. The third advantage, it is fast. Because it counts the frequency of words, it requires relatively low computational power compared to other NLP techniques. Another advantage, it works well for small data sets also. For some applications like spam detection, document classification, or basic sentiment analysis, backup words often provide good results. And next, what are the limitations of this? So already I have explained, it ignores word order because for example, I love NLP and NLP love I contain the same words but arranged differently. Although the meanings are different, but backup words treats them almost the same because it only counts the occurrence of word. And the second limitation is it ignores the meaning of words. For example, car and automobile have similar meanings, but backup words treats them as two completely different words. So for this reason, it often produces sparse matrix. This means that the document term matrix contains many zeros because every document uses only a small subset of total vocabulary, and for large data sets with thousands of unique words, the matrix becomes very large and it contains mostly zero values. This is one of the disadvantages of backup words. So it remains one of the most important techniques for understanding how text can be converted into numerical form. So far we have understood the theory behind the backup words. Let's switch into the Google Colab and see how Python and the Scikit-learn library automatically convert text into numerical vectors. This notebook demonstrates how to convert text into numerical features using the bag of words model. First, we will import the CountVectorizer class from the Scikit-learn library. Scikit-learn library is one of the popular Python library used for machine learning. CountVectorizer helps us to convert text document into numerical vectors using the bag of words model. Now let's run the cell. it will not produce any output because we have only imported the record class. Now we create a list of documents. The list contains 3 sentences. First sentence is I love NLP, second is I love Python, third is I love NLP is interesting. So these sentences will be our input documents for the bag of words model. The printer function simply displays the documents. So let's execute this cell. So see, all 3 sentences are displayed. Next, we create an object called Vectorizer using the CountVectorize class. After that, we use the fit transform function. This function performs 2 important tasks. First, it scans all the documents and collects every unique word. This collection of unique words is called vocabulary. Second, it converts each sentence into numerical vector based on how many times each word appears. The transformed data is stored in the variable x. So let's run the cell. Now let's display the BoW words matrix in a readable form. First we import pandas, then we create the data frame. After that we will convert the numerical matrix into normal 2-dimensional array. So that's why we are using x dot 2 dot array. So it will, you can see that it will give you all the values. These are the backup words. Like from these 3 documents, these words are present. Interesting, is, love, NLP, Python. These are the words present. It will show how many times the word appears in the record. So that is, if it is present, it will show 1, otherwise it is 0. Each column represents one unique word from the vocabulary. The numbers indicate how many times a particular word appears in the document. If the value is 1 means the word appears once. Value is 0 means which does not appear in that sentence. So this is exactly how the backup words model converts text into numerical data. Next we will try this example. See how many times this from first row it appears 0 times, and all this appears 1 time, and NLP appears 1 time, like that. 2 means 2 times the particular word is there, like that. 0 means the particular word is not present. Let's try another example with the different sentences. First, we create 3 new documents. The first sentence is machine learning is interesting, and the second one is deep learning uses neural networks. Next is I love machine learning. Again, we use CountVectorizer. It functions, it builds a new vocabulary from these 3 sentences and convert them into numerical vectors. After that, we use data frame using the transformed matrix and assign the vocabulary as column names. Finally, we display the data frame. Let's run the cell. See here, we can see a new bag of words table. Notice that vocabulary has changed because we used different sentences. Words such as machine learning, deep, neural networks, interesting, and love become the column names. Each row corresponds to one sentence, and each value indicates how many times a word appears in the sentence. For example, the word learning appears in all 3 sentences, so each row contains a value for that column. A word deep appears only in the second sentence, so its value is 1, only in the second row, and 0 in the other rows. Similarly, machine appears in the first and third sentences, but not in the second sentence. This clearly demonstrates how the bag of words model represents text as numerical feature vectors. So it is more suitable for machine learning algorithms. So that's why bag of words converts into numerical vectors. So this is the overall working procedure of this bag of words. Next we'll see some quiz question. So bag of words converts So we know that it will convert text into numbers. So the options are images, audio, and text into numbers, then videos. So why we need to convert text into numbers? Because we will be using machine learning algorithms. That algorithms will not understand text, so that will be converted into text will be converted into numbers. So it is more suitable for machine learning algorithms. So the next question is the bag of words considers. First option is word meaning, the second one is word order, third is word frequency, and fourth one is grammar. Already we have discussed. It will see only the frequency of the word, that is how many times the word appears. It will not see the meaning of the word, and it will not see the order of the word. And grammar of the sentence also will not be checked by back of words. Only it will see the word frequency. So the correct answer is answer C. So that's all about this video. In next class we will see some more interesting topics about NLP. Thank you everyone. Thank you for watching.